Welcome to this video. I hope you tried the last exercise with set reset and reset set flip-flops, and now we're going to use that in an industrial applications. So get ready with your programming knowledge and let's program a simple box sorting, but we will proceed step by step. So far you have learned how to latch and unlatch and how we can use RS and SR flip-flops. We're going to use the knowledge which you have learned so far to achieve one of the tasks of our simple box sorting. And in this task, we will see how we can latch and unlatch a conveyor, which we have already seen before. This conveyor using the buttons which are on the panel. So we have several buttons like e-stop, start button, stop button, and some indicators. So I already put these controls in my factory IO. If you want to have these files, you can go to wiki.codeandcompile.com, or you will find the link in the video where I have, not in the video, but in the resource section where I have uploaded everything. But otherwise, you can just go to wiki.codeandcompile.com. There you will find all the resources, downloadable files. So in this environment, what do we have? We have here an e-stop button. You can see on the top, start button, stop button, reset button, conveyor run, stop, and reset required. So we have to use these controls to latch and unlatch the conveyor. Most importantly, we have to also make sure with e-stop switch, the start button should not trigger the conveyor. So when e-stop is pressed, nothing should work. The machine should stop. And when you release the e-stop, this light indicator should be on, which says, okay, when e-stop is released, you need to reset the situation. Then we have to press this reset, and then we can stop the conveyor. Okay. How we can do that? We will use CCW software, and we will make a logic here. So this is the logic from the last slide. So let's start the PLC program. So we will not do the sensors at the moment. We will just take care about the inputs and outputs from the panel. Okay. So our task is to latch and unlatch the conveyor. All right, sorry. So our task is to latch and unlatch the conveyor using the buttons. So first step we need to do is we need to check how our factory IO is linked to the inputs. Okay, this is the step one. If you don't have factory IO, you can download from our website. I hope you know that. So I'll go to my drivers, and here I will select Allen Bradley Micro850 as my driver. And here I have my inputs. So at the moment I have two sensors and start button connected. Okay, so I have to make sure what I'm connecting to which inputs, because then we have to program the PLC. So this is like wiring the PLC, but virtually. So let's say I take my e-stop button on the top, and you will notice this is green because e-stop is an NC contact. Okay, NC switch. So this is already true. Then I will take my start button, which is this one. And then I will take my stop button, and then I can take my reset. Sensors I don't need at the moment, so I will just stick to these four inputs. And the output, what do I have? I have a conveyor, and conveyor run is actually an indicator. So if you notice here the outputs, this is my conveyor run indicator, conveyor stop indicator, reset required indicator. Okay, it's totally up to you. How do you name your outputs? So I have conveyor, conveyor run 001, and then I can put conveyor stop, and then I can use reset button light, reset required, start button light, stop button. Okay, I can do this like this. Lights I will do in the end. So the moment I have conveyor, and let's say conveyor run stop is fine. Reset I bring in the bottom, then start button light, stop button light, reset button light, and reset required. And furthermore, what we can also do, let's bring it down. Conveyor run I can bring here, and conveyor stop. Okay. Oops. Conveyor run. This is not here. So conveyor is my conveyor. Conveyor run is the indicator that conveyor is running. Oh, I don't need two of them. Conveyor stop indicator I have. Then start button light, stop button light, reset button light, and reset required. So we have 7 outputs and 4 inputs. And why this is showing a red icon here, because this tag is not configured in my Allen Bradley Micro850 PLC. So I have to configure that. So if you remember from the last lesson when I told you how to link these two software together, let's check it out. So this is my PLC, that's my old logic, I will delete it. And let's go to our global variables. And there I have defined my variables here. Only input 3 until 0 to 3. How many we need? Also 0 to 3, but the outputs we need from 0 to 6. So I have to extend the outputs. So I can maybe add a variable here. Oh, usually come in the bottom. So I will just copy this. And let's call it 3 and 4, 5, 6. And it was up to 6. Perfect. So this is done. Now I can just download it to my PLC. Let me quickly check my path. It's correct. And my PLC is connected. I will just download it now to the PLC, which will take a couple of seconds. And then you will notice that this red icon, which was in Factory Hour, it will be gone because now Factory Hour can see that these tags are defined in the PLC and it can read and write. Okay. So it's trying to download. It succeed, no failure. Download. And let's go back here and notice that this should go away. Let me just disconnect, connect again. Now everything is fine. So Factory Hour has a good connection with my PLC. Okay, now comes the PLC programming part. So let's disconnect. Now here we have to notice when we are starting the program, we have to see who has the higher priority. So in this case, let's say we have the highest priority of e-stop switch. This is a safety switch. If this is pressed, everything should be stopped. So let's focus on that switch first, okay? Now we know that this switch is NC, so it's already on. So let me just write the comment here first. Emergency switch logic, okay? So, and this emergency switch is my first input. So if I want, I can also put here as alias e-stop, input 0. This was, I need to check again, start, stop, and reset. So I will just put the name, start, stop, reset. And similarly with the output, let's see, output 0 is conveyor run indicator. Copy this. This is conveyor stop indicator. And then I have start button, stop button, reset button, and reset required. Start button indicator. Copy, paste, stop button indicator, paste, reset button indicator, and reset required. Perfect. So now we have our comments, so I can use that very easily now. So now what should happen with emergency switch? We will take a memory bit or a normal variable. So let's go to the local variables. This is my local variable. And I will put here e-stop condition as my, oops, maybe it doesn't take minus, as my a bit which I want to trigger when e-stop is pressed. So I will set this bit. Okay, so this is a Boolean bit. So I come to the main logic and let's take a contact. Okay, now you have to make sure which contact you're taking. If I take a normally open contact for the e-stop, so if I do like this, this is my digital input 0, 0. Here, better e-stop. If I do like this, this will always be true. Okay, this will keep on giving a signal, but I want a signal when e-stop is pressed. In this case, I will take an NC contact. Okay, once we go online, I will tell you why I took NC if you have a confusion. So I took my e-stop as my NC contact, and now with this e-stop, I want to set a bit, which is my e-stop condition, which I just took in my variable. Okay. Okay, so in this case, I will take an instruction block. All right, so let me just take an instruction block. You can also do set call, reset call, but since we did instruction block in the last videos, I will take this one. Now, the question is which instruction block, SR or RS? Now we have to notice when e-stop is pressed, it will set a bit. And I told you e-stop has a higher priority over anything. So in this case, we give priority to the e-stop, but not on the reset button. So in this case, we will take RS flip-flop, because this flip-flop, oh sorry, not RS, SR. SR flip-flop set dominant, because this will dominate the e-stop condition when e-stop is pressed. And here I will took an NC contact of e-stop, and let me just see if this is possible, if I can take here NC. Okay, this Allen Bradley does not support such kind of connection, I guess. Okay, so what we can also do is, let's just take the normal set coil. So I will take a set coil here, and here I'll take my local variable e-stop condition, and I will use this e-stop boolean input. Unfortunately, we do not have possibility to connect in parallel to this instruction block, so I had to use this one. That's another reason why I like FBT and structure text language more, which I will tell you later in the videos. Anyways, this solves our purpose. So when e-stop is pressed, my e-stop condition is set. Okay, and when this should be reset, it should be reset with a reset switch. Okay. So we will take another rung in parallel. So right click, and then you can do add rung. Oh, sorry, add insert rung below. This I don't need. Display comment. Okay, now here we will take when e-stop is pressed, and if e-stop is pressed, and if I press reset switch now, for example, it's very important to know. So our situation, if this is pressed, and if you press reset here, it should not reset the condition unless e-stop is released. Okay, this is we have to make sure. So if it is in press state, this should not do anything. It should only do anything if this is released. In this case, this is for the safety. So when this is released, we have an NO contact, which is true for this e-stop. So here I take e-stop, my input. So when this is released, and when I press reset button, then I will put this in series, global variable, reset. Okay, this should reset the reset condition now. Okay, this will be super easy to understand. Let's download and check what we just did. So it's just a combination of NO and NC contacts of your physical switches and a coil inside. Let's download and see the result. So it's downloaded, successful, it's running. All right, now let's have a look. So this is my condition. I will try to shrink it. This looks better. Maybe making more space. And this could be like this. I can try to align it. Okay, now have a look. Right now, e-stop is pressed and now it's released. Okay, let me see if this is, yeah. So now it's released. Let me just reset the circuit once. Okay, now at the moment you can see e-stop is not set. E-stop is released. Everything is working fine. Now when I press the e-stop, it will set my e-stop condition. And this e-stop condition should not reset when this is pressed. So this I can show you. When I press the button, you can see my reset button is true, but because e-stop is pressed, it will not reset the e-stop condition, which which is fine. Now if I release my e-stop, now this is true here, this is false here, and now with my reset, my e-stop condition will be false. Okay, this is how you have to make an e-stop circuit. This is extra secure. Now with this reset required, we should get an indication. So what we can do is, with the output of this set, we can trigger a reset required. So we know that now the reset is required. This will make it more interesting to see. So let's give it a try. I will try to bring it like this and maybe make this much bigger. So in this case, I will do something like very simple, add insert rung below, and I will just take e-stop condition direct contact, and with this I will take an output. You can also set here, but I find this way is easy. So reset required is output 6, and let's download it now. So in this case, we have an indication when the reset is required in our system. So you don't have to manually check if e-stop is pressed or released. You have an indicator to tell you if e-stop is required or not, e-stop or reset is required or not. Now we can have a look. Reset required, perfect. And then you can, oh, wait a second. Oh, I did a mistake. So this reset required should only be true at this state. I made a tiny mistake. So what you can do is, I will add here, when e-stop is released and stop condition is true. So there are two, let me just go back. So when e-stop is released and stop condition is true, then reset is required. So I will take when this is release, copy, paste. This makes sense. This is release. E-stop condition is true. Yeah, now we will see the correct way to reset. Downloading. And here we go. Yes. All right. Now you can see reset required is false. Let's go to our logic. Okay. Now I press the e-stop. So e-stop is pressed, e-stop condition is true, and this is going to stop our conveyor. We will do that in the next lectures. And now when I release it, you can see now it says you have to reset the circuit before starting it. So I can't start at all because I have to reset the circuit. And this will reset my circuit. Okay. Once again, when something happened, you go press e-stop. And for sure with this e-stop condition, we're gonna have another LED which will blink, or maybe our conveyor stop. We can trigger that as well. And then you release it and then you reset it. So that's a simple logic you can make for emergency switch for the panel. Okay. You can do the similar way if you have more emergency contacts or emergency stops or some safety switches in your control panel. You can link that in series to this e-stop. Okay. So this was about how you can do e-stop condition. And now next what we're going to do is we're going to make a tiny bit more logic for start stop of conveyor. So the starting stopping of conveyor should happen when e-stop is not pressed. So which means when e-stop condition is false. All right. So what you can do here, I will add another rung below and I will write start stop conveyor logic. So in this case, let's take first situation when e-stop condition is false. Okay. So I will take, when this e-stop condition is false, we take an NC contact as an interlock. So e-stop condition is false. And now after that, if I press start, which is my first input, second input, I will go here and global variable start. This should be able to latch my conveyor. Okay. So I will do set coil. And here I have my conveyor. The conveyor will be latched. And if I press NC switch, this one, conveyor should be unlatched. Another thing, if I press both NO plus NC, then also it should be unlatched. It's like RS flip-flop. So what you can do here, so when you press stop and if true is start is also true, this should not work at all. The green button should not actuate anything. So we have to interlock somewhere here. So here we can put, let's first make a branch circuit. Maybe I can do another rung below. So now this is again an NC button. So its NO contact will be true all the time. So we will take NC contact, because this NC contact will be true when you press the NC switch. So you have your stop, and this is going to reset my conveyor. And this should also only happen when your e-stop condition is there. So I will try to bring it here. So e-stop condition is not there. And with the stop switch, it will reset the coil. So it will reset my conveyor. And now when you press start, it should not set if this is also pressed. So we have to interlock that. So in this case, if this is pressed, its NO contact will be false. So I will take here also stop. So now what will happen? Let's have a look. Let's have a look how our start and stop or latching and latching is happening. Of course, we need to add some more elements to that, but I will go step by step. Let's download. So it is downloaded and it is started. Coming back, let's go online. Okay, now at the moment when you start the circuit, because it's NC, so e-stop condition is set. So we just need to make sure we need to reset the circuit in the beginning. Okay, now there is no e-stop condition. So you can see this is true and this is also true. And here if I press start, and you can see that stop, oh, this should be true. Let me check that, why it's false. Boolean input 2 is stop button 0. This is disconnect, connect. Oh, now it's true. All right, so this is red is true. Okay, so sometimes I'm confused why it's red. So now you can see that this is true, this is false, this is true. So when I press start, it will set my conveyor. And now you can see my conveyor is running. And when I press stop now, here, this will reset the conveyor. So this is reset. Again, this is set the conveyor, and the red button will reset the conveyor. Okay. Now, another important thing, what will happen if I start the conveyor and I press e-stop? Technically, it should stop the conveyor, but we didn't make that logic now. So if I press here, nothing happened. Although this gets false, now I can't even stop the conveyor as well. So what we need to do is, we need to make a logic such that if I press e-stop, my conveyor is also reset. Okay, so conveyor should be reset with my e-stop condition. When e-stop condition is true, conveyor should be reset. So this I can do in the parallel. There are countless ways to achieve that, but the easiest way which I found here is we need to reset the conveyor. I can do insert branch, and I need to bring it here. Oops. The way is you bring it inside. So when e-stop condition is true, it will always reset my conveyor. So I can do that a contact here, and that's my e-stop condition. Okay, this will reset my conveyor, and then this circuit will work. Let's download and have a look. How does it work? Download. You can also practice that simultaneously in your simulator and factory IO, which will work. So this is done, and now you can see that conveyor is stopped, because in the beginning we always have e-stop condition. So I'm going to reset that. All right, now what we need to do, we need to check the circuit. So e-stop is released, everything is fine. Stop button is not. Okay, this sometime your input and output are not properly refreshed, so I have to press it manually. Anyways, So this is just a software bug. I start my circuit. Now my conveyor is running, and I press e-stop, and now my conveyor is stopped because my e-stop condition is true. So if I release, my conveyor is still stopped because my reset required condition is still required. Reset is still required. So I press reset. Now system is reset and I can start again. Now what happens if I press e-stop and I press start? Nothing will happen. You can see because my e-stop condition is true. If I release e-stop and I press start, nothing happened because my e-stop condition is still true. It will only start when my reset is pressed to acknowledge the e-stop, and then you can start the system. And you can stop the system as well. Okay? So this is about how you can start and stop the conveyor and make e-stop your priority to stop the whole system. Next, what we're going to do is in the next video, because this video is getting long, we will just add these indicators to indicate the running and stopping of conveyor and the indication on the buttons. All right. See you in the next video. Bye-bye.